Hi, my baby chemists. This is Mrs. Salvans, and we're going to talk about a couple of one of our last items in our packet for gas laws. This is on page 3, and we're going to talk about density of gases. And remember, density equals mass divided by volume. And what we can extrapolate from this is at STP, remember we know that molar volume, or the volume of 1 mole of a gas at standard temperature, which is 273 Kelvin, and standard pressure, 1 atmosphere, or its equivalent, is 22.4 liters per mole. So that's going back to our stoic unit. So what we know about density of gases is that the higher the molar mass, the more dense it will be. And we can relate these using this equation. Molar mass equals dRT over P. So molar mass, density, our ideal gas law constant, temperature in Kelvin, and pressure. So, and this will explain the variables there. So if we look at our problem, it's asking us to find the density of a gas. It's 1.2 grams per liter, again, mass per volume, at 745 torr and 20 degrees Celsius. And it's asking what our molar mass is. So we're in torr, so we can use the ideal gas law constant for torr. We're in degrees Celsius, so we need to convert that to Kelvin. So we're adding 273, and then we have our equation here. Molar mass equals dRT over P. So at this point, we're going to start plugging it in. Our density is 1.2 grams per liter times our R. Since we have this in torr, we can look at our gas law constants and use the one that is in torr. So that's going to be 62.36. 62.36 liters times torr divided by mole Kelvin times our temperature in Kelvin is going to be 293 Kelvin, and then divided by our pressure, which is 745 torr. We're going to then put it into our calculator. 1.2 times 62.36 times 293 Kelvin divided by 745, and I get 29.4305, yada, yada, yada. All right, so now let's look at sig figs and units. So if we look at our units, what units cancel? Remember, units are going to save your acetate. So we've got liters and liters, Kelvin, Kelvin, torr, torr. What we've got left is grams over moles. Well, that's what molar mass is. It's the mass per 1 mole. And then if we look back at our givens and see what our units are, looks like we've got 2, 3, and 2. So it looks like our answer could be in 2 sig figs. Is this 4 going to make that 9 round? No, so that'll be 29 grams per mole. So that is on page 3, and that is the example.